a book called Scarcity. So that's it from me. We'll begin our session now with Professor Emily Oster.
Okay, so thank you. I'm very excited to be here. I thought a lot about what I should talk about today. And, I thought maybe I should say something general about big data, but like the only thing I could think of was like big data is very hot right now, and which is not very specific. So I thought instead I would just talk a little bit about a project that I'm working on that I think fits in this category of kind of what is the promise of big data, gives a little bit of a sense of what are some of the pitfalls and some of the limitations, but tries to get at a question that I think people would often think about with small data, with big data. So this is a project about dietary change in response to a health shock, which is kind of in the space that a lot of my work is in. So the motivating question, this is actually motivates a lot of what I work on, is that people do not always behave in ways that are optimal for their health. So there are many examples of this. People avoid cancer screening, they don't get genetic testing, even when it would be informative. They keep having unprotected sex, even when HIV is prevalent. And the particular issue I'm going to talk about today is that a lot of people are overweight. And for economists, these behaviors are very puzzling. So we look at people who are overweight and we say, like, I don't understand, this seems very non-optimal. Don't you understand? If you just had fewer calories, you would lose weight. Anybody can see that. Like, what is going on? And there are some rational reasons why people might behave in these ways. So one of them would be, for example, people don't care about survival. Another one is people just have no idea how to improve their health. And I think both of those are actually explanations that may have some traction. And then there's a sort of set of explanations that I would say are not quite rational, which are more in the space of like people would like to change their behavior, but they can't for some reason, despite having good intentions. And I would argue that understanding which of these explanations is most important is actually crucial to thinking about how we would combat the obesity epidemic, as the example, and thinking about what kind of interventions will be most effective. So how could you how could you sort of start thinking about these questions? So one option is you just ask people, like, why can't you lose weight? And that's a good approach. I think you learn something from that. But there are some issues. One is they probably don't know. The other thing is, they kind of want to tell you the stuff that you want to hear. They're like, oh, I really want to, but here's why not, and so on. And the other thing is bringing in people who are people who come in to talk to you about the question of why can't you lose weight are in fact probably people who do want to lose weight and who are sort of selected in a particular way. Another option is you could just study sort of interventions, like what helps people lose weight, what kind of interventions encourage weight loss. This has its own set of issues. It tends to be pretty specific to sort of particular diets. Again, it has this issue of attracting a selected sample, and it also has this broader issue that kind of people know that you're watching, and that impacts their behavior. So I'm going to take an approach to this, to sort of thinking about this problem by using some of what we call big data, and trying to use it to learn something about behavior, which we might be able to use to inform some of these questions. The particular kind of data I'm going to use is scanner data. So this comes from something called the Nielsen Home Scan Panel, and actually probably a lot of your universities subscribe to this. So in principle, this is data that you could have. The idea behind these data is that individuals who are enrolled in this panel are asked to scan all of their grocery, pharmacy, supercenter purchases. They have a hand scanner at home. It's like you go shopping, go to Whole Foods, you go to Star Market or whatever, you come home with your bag of stuff, and as you take the stuff out, you zit, and you scan it, and it enters the database. The database is very big, okay? What you see in the data is every one of those things that the people scan. I have the data for about 10 years. There are over 100,000 households. obviously not everybody's in for all 10 years. I don't think anybody's in for 10 years, but many people are in for sort of periods that are quite lengthy, a couple of years. And again, we're seeing, in principle, every transaction. And so that's a lot of data. These data sets are very large. My computer takes a very long time to load them and so on. And the advantage, if we're interested in thinking about questions about diet, is like there's a ton of data. And I see all this stuff about what people buy. It seems like, I can see all their food, like there's gotta be something there. The disadvantage is that it is totally not obvious what the treatment would be. It's like just observing a bunch of stuff that people eat. Most of what you could say is like people eat a tremendous amount of junk food. That's definitely true. You can see that in the data. That's not actually an insight into behavior. So what I do in this paper is I try to think about, is there something else in these data that would help us that would be a treatment, something which we would expect people to react to that might help us understand some of these questions. And the thing that I'm going to use is the fact that in addition to grocery purchases, we also observe pharmacy purchases. And I'm going to think about people who are diagnosed with diabetes, and I'm going to look for a pattern in the data, a pattern of purchases that is indicative of such a diagnosis. And in particular, what I'm going to do is say, let's take people where for a long period of time, I don't see them purchasing any testing products. So if you're a diabetic, you have to use products to test your sugar levels. So I'm going to see a long period where people don't buy any, and then I'm going to see them purchase some, and then I'm going to have that as a marker. I'm going to say that's an indication that something happened. People got some news about their health. And so once you if you like that, and there's a bunch more in the paper about why I think this is a reasonable approach, now we've again got this sort of population of interest, people who are likely overweight, who are probably resistant to behavior change. We have some treatment, which is they're sort of shocked by maybe some information, or some information arrives. And then we have this behavior, which is their grocery purchases. And then we can look at the data and we can ask the question, what happens to people's dietary choices after this event? And so the approach is going to be pretty straightforward. I'm going to show you some pictures where I'm going to estimate changes in calories. I'm going to look at the same household before and after this event. I'm going to look at sort of what happens before and then what happens after to their calorie purchases. And I'm going to use the fact that this data is incredibly rich, incredibly large, to look by food group. So I'm going to say things like, is it good foods? Is it bad foods? What exactly is going on? And then I'm going to try to, again, use some of the richness in the data to estimate some heterogeneity, to estimate some differences across individuals, and try to ask, does any of that suggest some explanation for what are the kinds of things that keep people from undertaking positive behavior change or encourage them to undertake such change? There are a lot of limitations of these data, in addition to the basic ones that sometimes it's better to talk to people. We don't see food away from home. We only see things at the household level. People may not scan everything. And I'm happy to talk more about those at some later time. But let me just say the data is not perfect, but I think it has some advantages. Okay, so here's the picture. Here's the basic result. So what we're gonna look at, the sort of treatment is gonna be like the first month that I observe you purchasing any diabetes testing product. And so we're gonna look at calories around that event. So here are the months leading up to it. It's pretty flat. There's actually an increase in the number of calories purchased in the first month. This is something we're trying to understand better. But subsequent to that, there is a decline, and that decline is sort of sustained out through about 7 months, which is kind of where the data, where we can sort of take the data and get a reasonable sample. This picture, although the magnitudes are hard to interpret from the way I've put it up here, when you kind of reinterpret the magnitudes, this I think gives us a clue as to some of the values of big data that Mike was talking about. So the effects here are about 2,000 calories per two-person household per month. And these households are purchasing an average of about 100,000 calories a month. Okay, so the effect sizes we're detecting here are maybe like 1.5% of calories. Okay, so that is a very, very small effect size. You think about applying that to like the number of calories that the average person drinks in a day or eats in a day, we're talking about reductions of something like 50 to 80 calories per day. So that's like a half a soda, basically. So, and detecting effects of this size would really not be possible without having just so much data and the ability to look at the same person, the same household over time, which really enhances precision. What am I pointing this? That probably makes sense. That's actually not a computer. Got it. Okay. When we then look at what kinds of foods people change their behavior most on, so the sort of most basic kind of breakdown I'm going to do is going to be based on some surveys of doctors. So I asked them, like, what's a good food, what's a bad food, and I had them sort of we have these categories of foods. All the doctors agree they're good, that's like vegetables. All the doctors agree they're bad, that's like pizza. And then there's some disagreement, that's like nuts. So here I have just the good foods and the bad foods, and what you can see, the orange line shows the good foods. You can see in kind of this first month, there's a little bit of an uptick in these good foods. Maybe people are trying to do something good. That goes away right away. So here I have this like mental image of people, like they buy their like bag of spinach, and then at the end of the month it's like rotting in the crisper, and then they never buy that again. Whereas the bad foods are kind of stable, and then they decrease, and that's really what's driving the reduction. And if you push in more detail on the kinds of foods that this is, you really find that like basically the declines in calories are being driven by declines in things like cookies, ice cream, oil, butter, like these sort of pretty large categories where people are purchasing a lot, like foods that are kind of consistently recognized as not good for them. Again, the declines are not that big, but that's where they come from. Okay, so following that, we want to try to understand a little bit more about the heterogeneity across households. And there's kind of two things I wanted to think about. So the first is sort of for economists, the place we'd often start with heterogeneity is demographics. We would say, like, people, rich people, highly educated people, those are the guys who are going to change their behavior more. Could be because they're better at understanding what they should do. It could be because their value of life is higher. There's various reasons. And it is like incredibly consistent that high education, high socioeconomic status people engage in better health behaviors. And indeed, in these data, it is true that kind of getting into my sample of diabetics is strongly correlated with demographics. So high education people much less likely to kind of appear in this sample of diabetics. However, once you are in the sample, and we then look at sort of subsequent behavior change, there is no relationship between education or income or any of these demographics and how much you reduce your calories. So contrary to basically what we'd expect, like high education people are no better at reducing calories than low education people. I think if you sort of introspect, like what might that mean? Well, I think if you're somebody, with a college degree who ends up in this sample, it may kind of tell us something about how much you must value this diet, given that a lot of people in that group have already kind of selected into healthier behaviors. The other thing we're going to look at is characteristics of the pre-diagnosis diet. And this is something where I think the data is, again, the sort of big data aspects of this are really valuable. We're going to think about what are the things about your diet in advance, and can we correlate your subsequent behavior change with characteristics of your pre-period diet? The particular thing I'm going to be interested in is people's diet concentration. So here's kind of the thought experiment I want you to have. There are two individuals, A and B. They both eat 10,000 calories a day, let's say. It's a lot, but they both eat 10,000 calories a day in 10 total food categories, where food categories like cookies, ice cream, soda. Individual A is 1,000 calories in each of those categories. Individual B eats 5,000 calories of cookies, and then his other 9 categories are kind of spread out on the other 5,000 calories. I'm going to refer to individual B as having a very concentrated diet. You want to think about that as somebody who basically has a problem. That guy's problem is cookies. He is very problematic cookie situation. The other person has a kind of broad-based problem, they eat too much. And so we're going to then look at whether that characteristic correlates with subsequent behavior change, and indeed it does, actually quite strongly. So here on the x-axis, I have these quintiles of concentration. So the 5th quintile, these are the most concentrated individuals. These are the people whose diet is like very heavily concentrated in one thing, and their behavior change subsequent to this diagnosis is much larger and is actually quite big. So these guys are predicted to have something like an 8 to 10% reduction in total calories, which is really, really quite a lot. So then, what does this tell us? Well, maybe not too much. I think in terms of revisiting some of these explanations at the beginning, we don't see much in the way of this sort of support for these kind of value of life stories. The thing that I've been thinking more about in light of this is this idea that I think comes much more from psychology, certainly not from economics, of the like perhaps simplicity in rules is helpful for change, particularly in settings like this where we've kind of selected a group who obviously are having trouble with this type of behavior change. And so, that kind of story where like when change is hard, simple rules are easier to follow, that would be consistent with this heterogeneity evidence if you think about the idea that like the guy with a concentrated diet, he could lose weight by sort of focusing on a rule, which is like no cookies. Whereas the other guy has to have a more complicated rule, which is like, just eat a little bit less of everything. And so, where do we go from here? I mean, I think we learned something from this, but I think it certainly falls short of really like being like, okay, this is it, now we know the answer to this question. I almost think this is a setting in which big data is helpful for kind of hypothesis generation. And so one of the sort of next, like where is this project going next? We're actually gonna try to like run an RCT with some people who are trying to lose weight and think about some like personalized simple diet rules as something we'd wanna test. And that's something that really came out of this analysis of data and sort of suggests a way to go forward. And so I think that's one of the many advantages of big data. I think that's one thing that we could push forward on where this would be helpful. Thank you. Am I getting down or am I? Okay, yes, yes, go ahead. Yes, please, sorry. You gotta turn it on, Michael. You gotta turn it on.
Anyone? Oh, it works.
Thank you. So when you measure the products that your sample people are purchasing, how did you know that the people actually purchase those products, consume them?
We don't. So yeah, so I think this is something that you're totally right. This is a limitation of this kind of data. I don't actually see that they eat them. What I see is that the household purchases these things, and again, as there's like, some of how I think about this initial bump up in the good foods and then a bump down is it may be that those foods were purchased and never consumed. Mm-hmm. And so I think this is sort of a downside, and you can think about like, what could you do that would be better? I think it'd be better in some ways if we could really get like detailed food diaries from people. On the other hand, you kind of never be able to get such detailed food diaries from so many people, and so we're sort of having this trade-off between these like detail versus kind of consistency in numbers, and I think that's a sort of central tension here.
Thank you so much.
Yeah.
So one of the things that seems cool about being able to have so much data is the ability to find different clusters, which I think is a lot, or something that's hard to do with traditional psychology data.
Yeah.
Have you looked at that as a way to break things down and look at subgroups?
Like based on what?
So in terms of purchasing patterns?
Yes, I've thought about that, and we haven't done, outside of this concentration thing, we haven't done that much of that, but I think that is a place to go in the sort of thinking about, are there diet patterns almost, or people patterns, or number of times you purchase. Like, you could almost imagine a machine learning algorithm which would try to like predict this stuff. Yes, machine learning also very hot right now, and so that is something we've thought about doing.
I was just wondering what programs you use to house such a big data set, and what program you use to analyze it.
It's in Stata. It's in Stata.
Oh, okay.
Yeah. Stata's really slow for this. It's like kind of like breaching the limits, but I don't know any other languages, so that was where I was stuck. I bet R would be better. Okay, I'm done.